Let us look at last question. This is a question from the quiz where we have to verify whether trace of AQB forms an inner product or not, where Q is a positive semidefinite matrix. So in order to prove whether trace of AQB forms an inner product or not, we have to verify three properties. So let inner product of AB is equal to trace of AQB. The first property which we should verify is linearity. That is A times A plus B times B inner product with C. We can write this as trace of A times A plus B times B QC, which is equal to trace of A times A QC plus B times B QC. We know that this can be written as trace of A times A Q times C plus trace of B times B into QC. This can further be simplified as A times trace of AQC plus B times trace of BQC, which is equal to A times inner product of AC plus B times inner product of BC. So linearity property satisfies. Similarly, we can show that next property, that is symmetric property, also holds. We can write trace of AQB is equal to trace of BQ, sorry, BAQ. But if we look at third property, that is positive semidefinite property, here the condition that has to be satisfied is trace of Q times A should be greater than or equal to and greater than or equal to 0, and trace of A times QA is equal to 0 if and only if AQ is equal to 0. So we can give a counter example and show that this fails. So for example, let A is equal to 3 minus 4 2 1, and let Q is equal to 0 0 0 1 multiplied by 3 minus 4 2 1, which is nothing but A again. So if we multiply these three matrices, we'll get our final answer as minus 8 minus 4 2 1. Here trace of AQA is equal to minus 1, which is less than 0. So hence this property fails, and thus trace of AQB doesn't form a inner product. Thank you.